Hi, my name is Tiffany, and this is Lab 4, Oscillations. Introductions. The purpose of this lab is to examine the motion of a spring mass system in which the mass oscillates on the spring. And then we use Tracker to extract the position data and then compare the observed motion against the predicted motion, which was calculated using GlowScript. And then we plot and then analyze the system's energy change through GlowScript. And so the goal of this lab is to determine whether the model follows the energy principle. So a brief preview of the results, the x and y positions between the predicted and observed motion were similar, but has variations. So the change in total energy is 0, the goal is reached. Some fundamental physics principles used in this lab are Newton's second law, which states that the net force equals the change in momentum over the change in time, and that F net is mass times acceleration. And then we use the velocity update formula and the position update formula. And then the energy principle, which states that the change in energy is equal to the work done by surroundings plus the thermal energy exchanged with the surroundings, as stated in these formulas right here. And K is kinetic energy, G is gravity, and then S is the potential spring energy, US. So this is observed motion through Tracker. Just a short video. Okay, so the object's mass was 0.402 kilograms, which is given in the pre-lecture videos. And then the initial position from what I captured was negative 0.101, negative 0.615 meters, and then initial velocity is 0. And this is what it looked like in Tracker, which is, it looks funky, but it gets there. Okay, and so these are the data in the GlowScript code that I edited. I put in the position of the ball, the mass of the ball, the velocity of the ball, and then these were the given data points in the pre-lecture video, so I just inputted that, and then I edited the equations, and so yeah, this is what it looks like. And so this is the video that I got from inputting my data through to GlowScript. I guess it looks kind of different from it looks kind of different, but this is what I got. I've tried many times, and this is exactly what I got like every single time. So I'm guessing I could be off, but this is what my graph looks like. Yeah, it looks very different, but yeah. Okay, so what are the possible sources of error? So in the real world, the system isn't and cannot be isolated like completely from the surroundings. So work is being done on the system, at all times. And so it's not perfect, and it could vary between the predicted and the observed. And so the center of mass could be off in Tracker due to my human error, and so that's why it looks so different. But yeah. And so what does it mean? Is the energy principle satisfied? So according to the graph, yes, the energy principle is satisfied. There are no external forces acting on the isolated system, so the energy change is 0 as seen in the graph delta E. And so the graph shows that the total change in energy is constantly 0, which you can see in the straight line, in the straight orange line. Um, and then comparing oscillation periods, so average oscillation period for the x component is 1.614 seconds, while the average oscillation period for the y component is 1.519 seconds. That 0.1 second off could be due to unaccounted forces like gravity and like air or something like that, and human error. And so choosing these different directions creates deviations, which affects the spring constant and the graphs, as you can see in my previous graphs. Yep. And that's the lab. Thank you.